In the earlier video, I had told that Z5 is a group under addition modulo n. Let us see how. So Z5 under addition is a group. Let me state it. Now, what are the four properties that it must satisfy, this set Z5, for it to be a group? First is the closure, right? So Z5 has these elements 0, 1, 2, 3, 4. We know that. So in general, any Zn, let me just tell it for your clarity, has elements 0, 1, 2, 3 up to n minus 1. How we got that? I have explained in the previous video. Now, if I take two elements a plus b, I'm adding them, I get a number or an integer c, which again belongs to Z5. How do I do this? I take 1 and 2, I add it. What is it? 3. 3 belongs to Z5. Now, if I add 2 and 4, it is 6, but I must divide 6 by 5 and the remainder happens to be 1. 1 belongs to Z5. Therefore, you take any two such integers a and b belonging to Z5, add them, you will get another integer which again belongs to Z5. Now, once this is clear, associativity must not be a big problem. I add a and b and add another number. You see that it will be equal to adding b and c and then adding a to it. You can clarify that by writing it down on a pen and paper. Now, this is true for every a, b, c belonging to Z5. What comes next is the existence of an identity in this set. So, if I take 0, add it to any other number belonging to Z5, I get back that number a itself. This is true for every element belonging to Z5. 0 is hence called the identity. Now, I'm writing 0 here. Doesn't mean it is only 0. Can also be 5. If I add 0 and 5, I'll again get 5. 0 added with any number will give me back the same number. What is an inverse here? Let us understand that. What is that number which when added to 1 gives me 0? What is that? If I add 2, I'll get 3, not 0. If I add 3, I'll get 4, not 0. And now if I add 4, I get 5. 5 divided by 5 gives a remainder 0, right? And hence 4 is the inverse of 1. 1 is the inverse of 4. Both ways it is true. Now, what is that number which when added to 2 leaves a remainder of 0 when divided by 5? The statement was very lengthy. You might want to pause and watch it again. If I add 3 to 2, I'm going to get a 5. 5 when divided by 5 leaves a remainder 0. And hence 2 is the inverse of 3 and 3 is the inverse of 2. It's an addition here and hence all these explanation will hold true, right? So we have seen that every element has an inverse. I have not explicitly mentioned about 0. It is very obvious that 0 is itself the inverse of 0. And hence Z5 under addition is a group. It is integers modulo 5. In general, it is true for any n. Zn under addition modulo n is a group. Now, you can try it out for Z2, Z3 for any n.